Welcome back, everyone, to our continuation of Organic Chemistry Part 4. This is lecture 59. We're getting there. We're getting there. Okay, let's review real quick what we've covered. We've talked about the alkanes, right? The single bonded or paraffin single bonded hydrocarbons. The formula CN. Take 2N plus 2 for the hydrogens. The alkenes, double bond, CnH2n. The alkynes, the triple bond, CnH2n minus 2. And then the alkyls, which are just alkanes missing a bond, missing one hydrogen, so it's got a free bond. Alkyls, 2n plus 1. Brilliant. So the alkyls are always an odd number. So those are going to be our additions, the methyl, ethyl, propyl, and all that stuff. All right, so let's do a quick review. Let's look at these and name them. You look at them, study them, and then we'll name them together, okay? So C2, 2 carbons is eth, 2n minus 2. So this is what? Ethine, right? 6 carbons is hex, right? N, 2n, so this is hexene, okay? Hexene. 5 is pent, 2n plus 2. 2n plus 2 is pentane. 3 carbons, MEP, so this is a prop. 2n minus 2 is propyne, Pyne. 7 is hept, 2n, and it's odd, so it's heptyl, 2n plus 1, heptyl. And 9 is non, 2n is 18 minus 2, so that's a triple bond, so that's no9, no9. Okay? So if I give any of these on an exam, you should be able to name them very easily. It's good. I just want to mention something you may see in the textbook, and I really don't talk about because it's a little more detail than we want to do, but I'll mention it and then we'll pretty much forget it. From the Latin, see, you never thought you'd be learning some Latin. We use the word cis, which means this side of, and trans, the other side of, okay? So for example, if I look at butene, double bond. If you see, I have a methyl and a methyl. So you see 1, 2, 3, 4. There's my 4 carbons. The double bond is on carbon 2, either way you go. So it's a 2-butene, and it's cis because they're on the same side geometrically. This is also called cis-but-2-ene, but again, beyond us. I'm just mentioning this in case you see it in the textbook and get all confused, okay? The other side of, you see the methyls, 1, 2, 3, 4, but these CH3s, the bookends, are on opposite sides geometrically, so this would be a trans-2-butene or trans-but-2-ene, that's called. But again, I will not be talking about cis and trans. I just wanted to clear that up in case you happen to see it in the textbook and have no idea what's going on. All right, good. What we want to talk about now are aromatics. Remember, you know the word aromatics. If something is aromatic, it has a smell. And with my big nose, I can smell everything. So aromatics or these ring structures, okay, rings. So what I've done is I've put a carbon here, 1, 2, 3, 4, 5, 6. I've put 6 carbons, so it's going to be a C6. And I've drawn it again, but you'll see why in 1 second. Now remember, organic chemistry is based on carbon. It's carbon chemistry. And carbon is in group 4A. So carbon wants to make 4 bonds, 4 bonds. If you look at what I've drawn, each one of these carbons only has 2 bonds, you see? 2 bonds. So I'm going to put an H everywhere. We're just going to do hydrocarbons right now, okay? Perfect. Still not right. Why isn't it right? Can you answer why this is not finished yet? Can you see? Well, again, back to carbon making 4 bonds. Each one of these carbons at the point where there's a carbon is making 1, 1, 2, 3 bonds, 3 bonds, 3 bonds, 3 bonds. It must make 4 bonds. So what I'm going to do is I'm going to put a double bond here. So see that line is going to be a double bond. I'm going to put a line here, double bond. I'm going to put a line here, double bond. So you see this double bond alternates. So if we look at this top carbon, excuse me, this top carbon is making 1 with the hydrogen, 1 with that carbon, and 2 with this carbon. So there's 2, 3, 4. This one has 2, 3, 4. This one has 1, 2, 3, 4. 2, 3, 4. So they all have 4 bonds. Why did I draw this again? Well, I'm going to draw this molecule again. I'm going to put the H's. You see where I've placed the double bond here, double bond there, alternating. So what if I alternate and I just do this? Okay, now the double bonds, it looks like the double bonds have moved. Okay, looks like the double bonds have moved. And actually, in real life, this structure goes between this and this. The double bonds essentially go around. So what we say, the language is that we say it's a resonance structure, or the molecule resonates between these two. The double bond just kind of rotates and alternates. So if you take a picture at any instant of this molecule, one instant the double bonds would look like this, the next instant the double bonds would look like this. They're both correct. Okay, so if we count the number of carbons, we had 6. If we count the number of hydrogens, we have 6. And if we look at our formula, all these formulas for alkanes, alkenes, alkynes, alkyls, we'll see that this does not obey any of the formulas. In fact, this ring structure, C6H6, is called benzene. Okay, nice carcinogenic. So this is going to be our basic benzene structure. So benzene is this. All right. Now, we don't want to draw this every time. This is a pain in the butt to draw every time. So what we do is we combine these pictures, and to show that it resonates, we just put a circle in the middle. You don't have to draw the hydrogen. So every time you see this structure represents C6H6. So it's a benzene. This is benzene. Okay? This circle represents the fact that the double bond spins between them. All right? This benzene structure. All right? Now, what are we going to do with this benzene structure? Okay, let's see. Just like with the alkenes, alkynes, alkanes, we're going to put some substitutions. So, I'm just going to draw this. So watch. Benzene. What if I do this? Can you guess what that is? Just try to guess. Try to name it. Can you do it? Sure you can. This is just a chlorobenzene. They're all chlorobenzenes. So if you have a substitution, it doesn't matter where you put it. It's exactly symmetrical about it. So this is chlorobenzene, this is chlorobenzene, this is chlorobenzene. It's good? Another hard one for you. What would that be? Obviously, fluorobenzene. Again, you could replace the CLs everywhere, just make it fluorobenzene. One substitution doesn't matter. Now, watch this. What if I made it this? Do you remember what CH3 is? Well, it's odd. And there's one carbon, so this is methyl. This would be called methyl benzene. Another name, if we had lab, we would know this, is called toluene. So toluene is methylbenzene. Same thing. Toluene is methylbenzene. Once again, it doesn't matter where I put the methyl group. It doesn't matter. Okay? So when you have one substitution, these are mono-substituted benzenes. Mono-substituted. Why mono? One. It's good? All right. Let's look at some silly ones, shall we? Again, it doesn't matter where I put these. Let's just look. C2H5. What is this? What is C2H5? Again, it's odd, 2 carbons. So this would be ethyl benzene. C6H13. It's odd. So what is this? Hexyl benzene. Wow, isn't that hard? Not hard at all. So mono substituted benzenes are very, very easy. We okay? All right, so let's get a little more complicated. And this is where you say, I knew it was going to get more complicated. Well, not really. It's systematic and it's not that bad. Okay? Once again, we're not trying to be organic chemists. We're just trying to get the basics down. Okay? So stay with me on this one. So let me just do this. There's my basic benzene, and I'm going to do something like this. I'll put bromine here. How's that? I'll put bromine. Now it's clear, you should know that this is a dibromobenzene, okay? We're going to just put dibromobenzene. Why is it dibromo? Oh, come on. Come on, it's obvious, right? There's 2. Now, look at this structure. I'm going to redraw it. And then I'm going to redraw it again. Put the Br on top. Now let's look. Is this dibromobenzene? Yes, 2 bromines. Is this dibromobenzene? Yes, 2 bromines. Is this dibromobenzene? Yes, 2 bromines. So what's the difference? The difference is obviously these are next to each other. These skip 1 bond, and these skip, either way you go, 2 bonds. So again, not knowing this molecule or what it is, I'll make something up. This one, when they're right next to each other, could be a sweetener for your candy. This one could be a dark black tar that's used on roads. I'm making this up. And this one could be a pink poisonous gas. They're all dibromobenzenes, but where the bromines are with respect to each other completely changes, whether it's a solid, liquid gas, whether it's poisonous, whether it's pink, whether it's black, whether it's sweet. So you have to tell me where those bromines are. Okay, I'll tell you. Can you guess? If this we would call 1,2-dibromobenzene, because one would be on carbon 1, the other on carbon 2, or carbon 1, doesn't matter. Can you guess what this would be called? Yeah, come on. 1,3-dibromobenzene, right? Come on, come on, you can do it. You can do it. 1,4-dibromobenzene. Okay? Simple. Chemists, here's gets a little crazy. Not really. Chemists, when they're next to each other, they also call this ortho. Ortho meaning next to each other. So this compound would be ortho-dibromobenzene. Ortho means 1, 2, next to each other. Okay? When you skip 1 bond, this is called meta. Meta means half, halfway. Ortho. And when you skip 2 bonds, this is called para. So this is 1,2-dibromobenzene, or exactly the same, equal would be ortho-dibromobenzene. This is 1,3-dibromobenzene, or equivalently meta-dibromobenzene. And this is 1,4-dibromobenzene, and equivalently this would be para-dibromobenzene. Okay, so you could use para, meta, or ortho, but I want to emphasize this. We only use ortho, meta, and para when there are 2 substitutions. Only for 2. You don't use it if there's more than 2 only 2 substitutions. All right, so ortho, meta, and para only for 2 substitutions. If there's more than 2 substitutions, we go back to the numbering system. The numbering system is always correct. Okay, so help me. And when we put substitutions on, It's the same idea as we did with the chains. We put them in alphabetically, and then we try to count which is the lowest number. So let me make something up. Okay, I'll make it nice and big. Benzene. Okay, so let's see. Let's try to name this beast. First, we have to see what do we have. We have bromine. This is ethyl. Remember what this is? This is pentyl. Bromine, ethyl, pentyl. Bromine comes first. Well, bromine comes first. That's going to be on carbon 1. Okay? So we'll call this what? 1 bromo. 1, so that's carbon 2, carbon 3. 3 ethyl. 4, 5. 5 pentyl. Benzene. Notice if I counted the other way, if this was 1, 2, 3, 4, it would be 1 bromo, 5 ethyl, 3 pentyl. But I think 135 is lower than 153. So I would count going that way. 1 bromo, 3 ethyl, 5 pentyl, benzene. Ta-da! Okay. Remember, when there's more than 2 substitutions, you use the numbering system, not para, ortho, or meta. Okay? Oh, these are just H's. Okay. Let's see if we can name this beast. All right. Let's see what we can do. All right, let's look. We have fluorine. What is C3H7? MEP. So this is a propyl, isn't it? Huh? 8 is octyl. So we have fluorine, octyl, and propyl, right? So F comes before, so we have, let's see, we're going to call this, we're probably going to go this way because O comes before P, okay? So I think this would be carbon 1, 2, 3, 4, 5, 6. So what do we have? We have 1, 2, difluoro, 3 octyl, 6 pentyl, benzene. It's good. 1, 2, difluoro. On carbon 3 is the octyl, and on carbon 6 is the pentyl. See, not that bad. These aren't so bad, are they? Okay. Let's do another one. What the heck? I don't know what this is, so let's try to work it out together, okay? So let's see what we have. We have a couple of bromines. What is this? This is decyl, right? 10 is dec. It's odd. 2 times 10 plus 1, decyl. What is this? MEPB, right? This is butyl. So it looks like butyl and bromine. Which way to go? Well, if I go this way, 1, 2, 3, 1, 2, 3. 4, 4, 5. So I think I have to count going clockwise. Okay? So I'm going to call this carbon 1. Let's see, no. 1, 2, 5, or 1, 3, 4. I think I'm going now. Okay, so 1, carbon 2, carbon 3, 4. 1, 3, 4. See, you can get a little confusing, right? Tribromo. You check this. Don't trust me. All right, so carbon 1, 2, 3, 4. Okay, on carbon 5 is my butyl. Okay, and on carbon 6 is my decyl. And that's a benzene. Okay, you have time. You go check and make sure I did the correct ordering, correct numbering. If I should make this carbon 1, 2, you see, okay? And you compare with the numbers we get here, and I'll try not to make things too confusing where you got to figure out which way to count and so forth, all right? So let's see. Let's give you, I'll give you one, all right, I'll show you. Let's look at this. All right, let's name this. And the reason I'm doing something like this is I want you to see there's a bunch of names for this. Watch. Well, we know this is what? Methyl. We know this is ethyl. So 1, 2, 3. So it's 1 ethyl, 3 methyl, benzene. There's 2 substitutions, right? So I can use the meta. So instead I could call this meta ethyl methyl benzene. Okay, they're equivalent. 1 ethyl, 3 methyl benzene, or meta, because you skip a bond, ethyl methyl benzene. Can anybody figure out another name for this? Can you see another name for this? All right, let's see. Remember methyl benzene was the same as toluene? I don't know if you remember that. So if I want to name this toluene, then this methyl group defines it as toluene. That would put this toluene on carbon 1. That would mean 2, 3. On 3, this would be a 3-ethyl toluene. Or if we want to go back to the meta, watch this. This would be a meta ethyl toluene. The ethyl is meta to what makes this toluene, which is the methyl group. So look at this. 1, 2, 3. There's 4 names for this molecule, which is correct. They're all the same. They're all equal. Okay, they're all valid. 1, 3, 1 ethyl, 3 methyl benzene. Meta, because you skip a bond, ethyl methyl benzene. 3 ethyl toluene, defining the methyl, this molecule by the methyl as toluene. So it's, if that's defines it to be toluene, then on carbon 3 is the ethyl, or that ethyl is meta to what makes this toluene, which is the methyl. So it would be meta ethyl toluene. Okay, you see it could be a little confusing, but it's not that bad. All right, so the substitutions on the aromatics, except if there's 2, we can use ortho, meta, and para. If there's more than 2, we always use the numbering system. Okay, there's a couple of other single substituted names for the benzenes. We did toluene, but there's a bunch of others, and we just won't do it. Okay, there's so many things, but we're just going to stay with the basics. I'll maybe give you toluene. All right, so this is the idea behind the aromatics. Again, aromatics are things that smell, and essentially everything to do with toluene, benzene, essentially almost all of them are carcinogenic. You do not want to inhale these things. You don't want to drink them. You don't want to put them on your skin. Uh, Not good for you. Okay. All right. I guess that's that. And I'll see you next time. Okay. Take care of yourself and peace.